Throughout history, the concept of time travel has captivated our imaginations. From ancient myths to modern science fiction, the allure of journeying through time has enthralled humankind for centuries. We've all wished we could go back and change the past or get a glimpse of the future. Stories like H.G. Wells' The Time Machine have sparked our imaginations, while movies like Back to the Future have entertained us with their whimsical and thought-provoking scenarios. These works of fiction often serve as a launchpad for real scientific inquiries, prompting us to question the nature of time itself. While the idea of time travel may seem firmly rooted in the realm of science fiction, it is a topic that has also been seriously considered by physicists and cosmologists. The quest to understand time travel has led scientists down fascinating paths, exploring the very fabric of space and time. Section 2. Could we travel through time? The theories that suggest it might be possible. While the idea of time travel might seem like something straight out of science fiction, there are actual scientific theories that suggest it could be possible. These theories are rooted in some of the most complex and mind-boggling areas of physics, like Einstein's theory of relativity and the perplexing world of quantum mechanics. These theories offer glimpses into the potential for manipulating time, suggesting that our everyday understanding of it as a linear, rigid construct might be far too simplistic. One of the most well-known theories that allows for the possibility of time travel is Einstein's theory of relativity. According to Einstein, time is not absolute but is relative to the observer's frame of reference. This means that time can be affected by factors like speed and gravity. Imagine two clocks, one stationary and one moving at a high speed. According to relativity, time would actually slow down for the moving clock relative to the stationary one. This phenomenon, known as time dilation, has been experimentally verified and forms the basis for many time travel theories. Another intriguing concept that emerges from Einstein's theories is that of wormholes. Imagine a shortcut through space-time, a tunnel connecting two distant points in the universe. While the existence of wormholes is still highly speculative, they offer a tantalizing possibility for time travel. Section 3. Bending time, relativity, and the possibility of time travel. Albert Einstein's theory of relativity revolutionized our understanding of space and time, suggesting that they are not separate entities but rather interwoven components of a single fabric known as space-time. This revolutionary concept, which has been experimentally verified, laid the groundwork for the possibility of time travel. One of the most intriguing aspects of relativity is the concept of time dilation, which states that time is not absolute but is relative to the observer's frame of reference. Imagine two identical clocks, one remaining stationary on Earth and the other traveling at incredibly high speeds, approaching the speed of light. According to Einstein's theory, time would pass slower for the clock in motion compared to the stationary clock on Earth. This difference in the passage of time is known as time dilation. While this effect is negligible at everyday speeds, it becomes increasingly significant as an object approaches the speed of light. Now let's imagine a spacecraft capable of traveling at near light speeds. If astronauts were to embark on a journey aboard this spacecraft, time would pass slower for them compared to people back on Earth. Section 4. Wormholes, shortcuts through space and time. Another intriguing concept that emerges from Einstein's theory of general relativity is the possibility of wormholes, theoretical tunnels that could connect two distant points in space-time. Imagine a piece of paper folded in half, with a considerable distance separating the two ends. A wormhole would be like a hole punched through the paper, creating a shortcut between those two distant points. While the existence of wormholes remains purely theoretical, they offer a tantalizing possibility for time travel. If we could somehow create or manipulate these cosmic shortcuts, we might be able to use them to traverse vast distances across the universe in an instant, potentially even journeying through time itself. However, there are significant challenges and unknowns surrounding wormholes. Section 5. Time travel in the quantum realm. A look at the subatomic world. While relativity offers intriguing possibilities for time travel on a macroscopic scale, the world of quantum mechanics, which governs the behavior of particles at the atomic and subatomic levels, introduces even more mind-boggling possibilities. In the quantum realm, the classical laws of physics break down, and particles exhibit strange and counterintuitive behaviors. One such peculiarity is quantum entanglement, a phenomenon where two entangled particles become linked even across vast distances. Imagine two particles that are entangled. If you change the state of one particle, the other particle instantly changes its state as well, no matter how far apart they may be. This instantaneous connection seems to defy the limitations of speed and distance, hinting at a deeper interconnectedness in the universe that we are only beginning to understand. How does this relate to time travel? Some physicists speculate that quantum entanglement could potentially be harnessed to transmit information faster than the speed of light, potentially even backwards in time. Section 6. Have we found evidence of time travel? Examining the clues. While the prospect of time travel is an enthralling area of scientific exploration, the question remains, is there any concrete evidence to suggest that it has ever occurred or could be possible? While we haven't discovered a DeLorean hidden in a garage or encountered any time-traveling individuals that we know of, there have been some intriguing anomalies and unexplained phenomena that have fueled speculation about the possibility of time travel. One such anomaly is the alleged existence of out-of-place artifacts or OOPArts. These are objects found in archaeological contexts that seem to be far too advanced for the technology known to have existed during the time period they are attributed to. Section 7. The Perils and Paradoxes of Time Travel. Untangling the mind-bending possibilities. The concept of time travel is rife with potential perils and mind-boggling paradoxes that challenge our understanding of causality, free will, and the very fabric of reality. If time travel were indeed possible, it would raise profound questions about the nature of our actions and the consequences of altering the past or future. One of the most significant concerns is the potential for unintended consequences. Even seemingly insignificant actions taken in the past could have ripple effects that drastically alter the course of history, potentially leading to unforeseen and undesirable outcomes in the present. This raises ethical dilemmas about the responsibility of time travelers and the potential for unintended harm. Another concern is the possibility of creating temporal paradoxes, which challenge the fundamental laws of cause and effect. For instance, if a time traveler were to go back in time and prevent their own birth, it would create a paradox, as they wouldn't exist to travel back in time in the first place. Section 8. The Grandfather Paradox, a classic time travel conundrum. The Grandfather Paradox is perhaps the most well-known and perplexing time travel paradox, highlighting the potential for logical inconsistencies and the challenges of reconciling time travel with our understanding of causality. Imagine a scenario in which a time traveler journeys back in time to a point before their parents were born. If this time traveler were to then kill their own grandfather, it would create a paradox. Section 9. The Bootstrap Paradox, a causal loop of events. The Bootstrap Paradox, also known as the Causal Loop Paradox, presents another mind-bending scenario that arises from the possibility of time travel. In this paradox, an object, piece of information, or even a person is stuck in a closed loop of time, with no clear origin or beginning. Imagine a scenario where a time traveler travels to the future and obtains a copy of a groundbreaking scientific paper. This time traveler then returns to the past, to a time before the paper was supposedly written, and gives the paper to the scientist who was credited with its creation. The scientist, unaware of the paper's true origins, publishes it as their own work, and the paper goes on to become a cornerstone of scientific knowledge. Section 10. The Fermi Paradox and Time Travel. Where are the time travelers? The Fermi Paradox, named after physicist Enrico Fermi, poses a perplexing question about the possibility of extraterrestrial life. Given the vastness of the universe and the high probability that other intelligent civilizations exist, why haven't we encountered any evidence of them yet? This paradox has puzzled scientists and philosophers for decades, leading to numerous hypotheses and potential explanations. Intriguingly, the Fermi paradox can also be applied to the concept of time travel. If time travel were indeed possible, wouldn't we expect to have encountered time travelers from the future by now? Section 11. Conclusion. Time travel. The final frontier? The concept of time travel continues to captivate our imaginations and push the boundaries of scientific inquiry. From the mind-bending theories of relativity and quantum mechanics, to the intriguing anomalies that hint at the possibility of temporal anomalies, the quest to unravel the mysteries of time travel remains a tantalizing pursuit. While we haven't quite cracked the code to building a working time machine or encountered any definitive proof of time travelers, the very fact that these concepts are rooted in real scientific principles is a testament to the boundless possibilities of the universe. As we continue to explore the cosmos and delve deeper into the nature of time itself, we may uncover even more mind-boggling phenomena that challenge our preconceived notions and open up new realms of possibility.